Okay, let's look at another question. So, an investor pays £400 every half year in advance into a 25-year savings plan. And you calculate the accumulated fund at the end of the term if the interest rate is 6% per annum convertible monthly for the first 15 years and 6% per annum convertible half yearly for the final 10 years. So how does this interest rate kind of look? Okay, so we've got I to the 12, which is the annual nominal amount convertible every month, and so that is 0.06 over here, which is when t is less than or equal to 15, and then we've also got I to the 2, which is 0.06 when 15 is less than t and t is less than or equal to 25. Okay, so essentially what are we trying to find over here? We're going to find the series for the first 15 years convertible every half year, and that'll be in 15 years time, but to find what the future value will be after 25 years, we're then going to have to multiply that by 1 plus the effective annual rate 10 years going ahead into the future, but that'll be using this annual effective rate over here whenever we calculate that, plus the series due every half year for the final 10 years, and no issues with that one over there. And then we're going to have to multiply this whole thing by £400, which is half yearly, so times 2, which is then 800. So that's what we're going to figure out, and that'll be our answer in pounds. Okay, so to start with, let's work out all our V's and I's and D's and so on. So to find this series bit over here, let's find that. So first we're going to need to find, it's going to be 1 minus V to the 15 over D to the 12. Okay, so I'm going to use Excel for this bit to just muck around and see how I can turn this 0.06 payable every month into a V and a D and so on. Okay, so we have I to the 12 is 0.06. So the monthly effective rate is equal to, just to make that bigger, is equal to that divided by 12. So the annual effective rate is equal to 1 plus the monthly rate, compounded monthly, minus 1 is that bit over there. So then we have V, which is equal to 1 divided by 1 plus annual effective interest rate, and we have D equals 1 minus V, and we also know that if we wanted to find, there are a few ways of finding it, but if we wanted to find D to the 12, essentially what we do now is we're going to say 12 times, well actually, we don't need to find D to the 12, sorry, we need to find D to the 2. And the reason for that is when we go back is that this bit over here is to the 2. So we can forget that we had a 12 in the first place. That's a waste of our time. So to find out D to the 2 is we're going to say 2 times 1 minus, move the mouse, 1 minus D, regular D, to the power of 1 over 2, or 0.5. Same thing, gives us that amount over there. So now, I think we can finally find A due to the 2, which is equal to 1 minus V to the power of n, which is 15 in this case, divided by D to the 2. Now we can find S due to the 2, which is, as I said, that amount times 1 plus the annual effective interest rate within the first 15 years, compounded 15 times. So we have that. Now we still have to get this for the next for the next 10 years going ahead into the future, but we need to find what the new annual effective rate will be going ahead. So we've found this bit over here, good job to us. We haven't yet found this, but we can use that once we've found this bit over here. So let's first find this series with a new rate. So we're saying that, I'll just put it over here, I to the 2. So this is, I'll just put down, this is first 15 years, and this is last 10 years, and so that can be together, that can be together. Okay, so we have I to the 2 is 0.06, so our biannual effective rate is going to be equal to that divided by 2, and so then our annual effective rate is equal to 1 plus our biannual one compounded twice minus 1 is that, so V will be equal to 1 divided by 1 plus our annual rate. D is equal to 1 minus V, as we all know, and then D to the 2 over here is going to be equal to 2 times 1 minus D. Sorry, D is over there, which we know is V, so I could use that if I wanted to, but I'll keep it like this. To the power of 1 over 2, which is again a half, close all the brackets, we get that. So A due to the 2, now this is through the last 10 years, is then equal to 1 minus V to the power of 10 divided by D to the 2, is that bit, and then the series S due to the 2 equals that bit, multiplied by 1 plus the annual effective interest rate there to the power of 10. So that's that bit. That's good. We're going to keep that. We're not going to keep this now. We just need to add this amount at another 10 years over here. So what we're going to do is we're going to take it and multiply it by 1 plus our new annual effective rate over there, the power of 10 years. And that's something we want to keep. And then we want to multiply all of that by 800. So let's see what the total is. That plus that, okay, so looking all right, times 800 pounds. And that's going to give us 46,702.66 pounds. That's the most important number that we want, because that's the answer to our question. So it is 46,702.66. That's what we'd write in the exam. So ask any questions if you're having trouble with it. That was a lot of steps to take to get just one number. But yeah, ask if you're having any trouble. Thanks for watching.